All right, guys, it's another episode of Tips and Tricks. I know we haven't done one of these in a long time, and today I'm not actually going to be writing anything down on paper. What I'm going to try and do for you guys is to decode how to read these graphs and how to do this whole thermal expansion lesson. All right, so on the classwork page, you've got 4 attachments. 3 of them are important. One is just me being bored on a Friday, giving you an Easter egg. But Miss Antoni was nice enough to give us a copy of her lesson 10, her thermal expansion notes. Okay, so that should be this page. Okay. A copy of the questions you're supposed to answer. That's this page. And then a second copy of basically the last page in the notes from the previous section. Whoops, I just closed it. Nice job, Burke. It's live radio, people. Okay. Basically the last page of this, but she said that got a little kerfuzzled. And some of it wasn't clear, right? So let's go through how to kind of read these things. So these problems kind of go through 2 phases. The first phase is going to be exactly how the question is being asked. Figure out what thermal process it is. And the way we're going to figure out what thermal process it is, we're going to look at starters. Choice A is A through B, right? A through B. So if we look at our graph, I'm starting up at A, and I'm moving to the right towards B. Now what you're going to do is, after looking at that, check your notes. Okay, the 10B is a good place to look. Look at your notes and look at what thermal process seems to be best represented by that path. And in this case, it looks an awful lot like this first option, which is isobaric. Iso meaning same, baric referring to pressure, right? So that means that during this process, pressure is going to remain the same from spot 1 in the process to spot 2. So you can cancel out pressures both sides. The pressure is going to stay the same, and that's phase 1. Okay, I've identified this as the isobaric process. The next phase is going to be, you're just going to start to use this change in internal energy is equal to 3/2 nR delta T. And depending on what process it is, Miss Antoni, again, was nice enough to outline what's happening to work, okay, what's happening to Q, and how that all interacts. And really, you're plugging in stuff from there. This particular lesson is a little bit more conceptual than necessarily mathematic, but I hope that clarifies how you're reading these graphs and how you're using these graphs. There are some extra little notes here, like this was the work done. This little shaded section is the work that was needed to bring it from point 1 to point 2. So when the gas expanded, it had to do this work, all right? And we counted that as negative work. So that's always the shaded section, okay? And that's basically what you're looking at here, okay? If you have any more questions, please, again, feel free to email me or to add a private comment. And I hope this was helpful, all right? See you guys soon. Bye.